Think of the last time you asked a language model to code a complex application using a single massive prompt. You give it a huge list of instructions, and it attempts to build all the logic, styling, and architecture at once. Without structure, that output almost inevitably falls apart. When one AI agent attempts to act as the software architect, the project manager, and the coder in the exact same breath, it suffers from context collapse. It loses track of dependencies, forgets key variables, and generates disorganized code that requires hours of manual debugging. A Node.js pipeline called Spec-To-Ship solves this by refusing to do everything at once. It runs a single process that divides the workload across 5 AI personas: an architect, a planner, an engineer, QA tester, and reviewer. Interestingly, this orchestration tool was built autonomously by another AI agent named Neo. Simulating a complete startup team working in sequence proves that reliably generating the code requires a strict division of labor rather than a single monolithic request. To see how this workflow functions, we start at the beginning of the pipeline, when a broad, raw feature idea first enters the system. This initial concept is handed to the architect agent. It absorbs the raw idea and outputs a comprehensive technical specification, explicitly defining the project's data models, API contracts, and security requirements. That markdown specification is immediately passed to the planner agent. Acting as an engineering manager, the planner reads the spec and cuts it down into smaller, actionable development tasks. This animation shows how those tasks are structured into a topological map. This is a mathematical way of ordering tasks so that step B is never started before its dependency, step A, is completely finished. By enforcing this rigorous upfront planning stage, the system ensures that absolutely no source code is written until a logical, dependency-aware blueprint is in place. Once the task map is set, the engineer agent takes over. It systematically works through each task to write strict, perfectly typed TypeScript code. But the code doesn't advance down the pipeline net. It is instantly routed to the QA agent, which generates exhaustive Vitest test suites designed to catch edge cases and validate the acceptance criteria. This animation illustrates the tight loop mechanism. If code fails a QA test, it is instantly rejected and sent back to the engineer. The two agents rapidly iterate, bouncing code back and forth until the implementation finally turns green and passes the test suite. Forcing this adversarial relationship between the writer and the tester acts as a physical barrier that prevents broken logic from sneaking downstream. The final audit falls to the reviewer agent. Stepping in as a principal engineer, it analyzes the complete package and scores the output out of 100 based on security, performance, and correctness. Underneath these agent personas, the system relies on invisible resilience mechanisms to stay alive. It uses exponential backoff, waiting longer intervals between retry attempts to handle server limits, and it automatically forces a retry if the AI outputs a broken JSON file. A human operator doesn't have to wait blindly for the final result. They monitor this entire process in real time through an industrial-style dashboard, watching the logs and statuses update as the agents work. Combining these strict testing barriers with robust error handling elevates the process from a fragile AI experiment into a reliable tool you can run locally. The final stage of the pipeline delivers a complete structured project directory directly to your local file system. This diagram shows the resulting output: markdown architectural specs, detailed task breakdown files, typed source code, complete test suites, and the final review log. Because every piece of this generated package has been audited and tested against itself, it is completely ready to be committed to version control for deployment. Large language models have evolved from simple autocomplete tools into autonomous engineering departments capable of running entirely within a local environment. By enforcing specific roles and structured handoffs between them, Spec-To-Ship proves that high-quality, end-to-end software development can be successful.